Perez, and I would like to show you a scenario about momentum.
Whoa, man, how'd you knock me down?
Oh, well, you see, I just use momentum.
What is momentum?
Momentum is the product of mass times velocity. With me being the heavier person and walking at a faster pace, I was easily able to knock you down to the floor.
Oh, well, gee, thanks, man.
Hey, no problem.
Hey, Sonny.
Yo, Alex, man, what's good?
Hey, man, I've been thinking, man. I want to learn more about momentum.
You want to learn more about momentum?
Yeah.
You came to the right guy, man.
Alright.
Let me tell you. When it comes to momentum, there's a lot of key things you need to understand. First off, the definition of momentum is the mass times velocity of an object is the momentum.
Yeah.
Now, a few things you need to know about momentum is that there are two types of collisions. Okay? There's elastic collision, being where if I knock into you, I transfer all my energy into you and send you away while I remain in place.
Okay.
Next is inelastic collision. Inelastic is when I knock into you, I transfer my energy to you and I take you away. Let me make another little sense?
Yeah, it's making sense.
Now, another cool thing about momentum is you can think of momentum kind of like a person.
Mm-hmm.
You know how people have to follow laws, right? Well, momentum has a law of its own. That law is the law of conservation.
Okay.
Now, the law of conservation states the total momentum before collision is equal to total momentum after collision. In other words, the momentum, right, is going to always remain constant. It's always going to be the same. If you're ever trying to figure out the momentum of some problem, right, if you're ever in physics class and you need to know how to find momentum, you need to remember this law to find the answer.
Sure. So I'm actually getting the hang of momentum.
Oh, for real?
Yeah.
Okay. How's about a little test?
But how?
I got a good idea.
Yeah.
You see my trash can right here?
Yeah.
Okay. I'm going to collide with my trash can. Okay. I'm either going to carry it, knock it over, bump into it, and then I'll fall over. And whichever one I perform, you have to decide whether it's elastic or inelastic.
Yeah.
Okay?
Okay.
Ready?
Yeah.
Okay, I'm gonna get it right now. What was it?
Elastic.
What was that?
Inelastic.
No. It was elastic. Because when I
Elastic?
collided,
Well, wasn't the first one elastic?
first one was elastic.
Yeah.
Because when I collided, I sent my energy into the trash can,
Yeah.
forcing it to move away. Now, the reason why this is inelastic was because my momentum wasn't. I didn't have enough momentum to knock over the trash can.
Yeah.
So the energy went back to me, which caused me to fall backward.
Makes sense.
Ready for the third one?
Yeah.
This will be a little bit.
What is this? Inelastic.
Which one?
Inelastic.
Inelastic is correct.
Yeah.
Because my momentum causes both to keep on moving in the same direction.
Okay.
I think you're starting to master this whole momentum thing. But first, I wanna see if you know how to measure momentum.
Measure momentum. What's that?
You see, when it comes to momentum, it's good to know what exactly it's used for and how scientists can record their data. For example, here in this bowling ball lab that I've done, you see that you can see that how momentum is measured with distance and time. Whenever it traveled a distance of 1 meter, the time was 3 seconds. At 2 meter was 5 seconds, and so on and so forth.
So what are the units for momentum?
The units for momentum is meters over seconds because we're using mass and velocity.
Good. Thanks.